biofuel companies to try to understand why this is not scaling up. And this is the result of the survey. The main barriers are stability in regulation, availability of low-cost capital, efficiency in the capex, so again related to that, and uncertainty in regulation related also to the level of subsidies. Actually, the one that is as a lower barrier is technology. So we can see that innovation in this case is not so much about technology in this case. It's really about the regulatory frameworks. And if you have seen the developments in policies from the governments, Thailand, for example, a lot of how can we subsidize, how we can put money. But when we see what governments are doing for bioenergy is how can we be more stringent on sustainability? How can we have more stringent regulation on that? So, which is important. But our feeling is that maybe too much stick and too little carrots for the bioenergy sector. No? So maybe something to keep in mind. But of course, we need to continue to ensure sustainability. For example, the use of blockchain for custody chains, very important. New business models to actually couple bio with other decarbonization pathway, that is synthetic one, and of course the feedstock, how we collect the amount of feedstock that we need for these applications. Okay. Second pathway, indirect electrification, with hydrogen. This morning we had a session on that. Again, you saw maybe this chart, but just for these synthetic chemicals, we will need more than 250 megatons of green hydrogen per year. And again, we discussed this morning, from where all this electricity would come from, what will be the impact on the grids, but something very important I hope today will be disclosed again is from where many of these will be hydrocarbons, synthetic hydrocarbons, which need a carbon molecule. So from where can we get this carbon to really ensure that they continue to be aligned with a net zero carbon pathway? So it's interesting, we need carbon for a net zero carbon. Okay, how can we do that? Location of facilities. Where are we going to locate these facilities now? Should they be located close to the renewable energy sources, above deserts with a lot of sunshine, but then we don't have biomass for the carbon? Or should we locate them where we have a lot of bio, but maybe we don't have wind? Or should we locate it close where we have ports to trade, import, export when it's needed, but maybe we don't have wind or bio there? Some places we may have these famous hubs that we are seeing now, but how many can we have on a world scale? Infrastructure, grids, pipelines, etc., and something very important. All of these great plans we have heard this morning are mainly about greenfield plants, new plants and so on. But we still have a big problem, the brownfield plants. What are we going to do with that? But today our expert will tell us what we will do about that. Right? And the last one, the direct electrification, more in a more early stage. But today we have also some progress. We have BASF here today. We heard the news that they are piloting now, starting demonstration for an electric cracker. Same with Shell, and now we also know that we have now higher temperature heat pumps up to 200 degrees. We have electrical furnaces, we have plasma, etc. So we are going higher and higher with direct electrification. But there's still technology, innovation to continue to develop the technology, the peak load of these solutions, and also how to manage the variability, because the processes need a stable energy, heat, electricity supply. So how to manage those variabilities, so also important. So again, you know this, our toolbox, which is the one for heating in industries, combining different innovations in technology, market, system operations, business models. Very important, the sector talking about. Maybe you have heard, I think if I may say something about Voltachem, this is an announcement of electrochemical reactors, where in one reactor you have two reactions, using electricity, but also with bio feedstock. So combining bio, efficiency, and electrification. So how promising is this? Maybe we will hear about that later. But creating new approaches, business models. Every sector is different also, so it's very difficult to have, like, you know, methanol and ammonia, complete different beasts, complete different animals. One needs carbon, the other don't need, one has hazard and toxicity, the other is different. So we need to better understand each one of those. It's not possible to have really one unique pathway for all of that. Last slide. So we in IRENA have the Alliance for Industry Decarbonization. It's an alliance of companies committed to a net zero carbon pathway, and we have a number of companies that have participated today already in there, like for example Enel, Repsol, we have this morning, we have ENI here, but maybe some of you are not yet. If you are interested, we will be very happy to also let you know how you can engage in this alliance. So, okay, with that, I would like now to give the floor to our moderator, Florian Ausfelder. Florian is the head of the Dechema subdivision in energy and climate, and he also leads some of the working groups in these topics. He is very much at the front of how to change these chemical industry processes, alternative energy sources, CO2 utilization, as well as PTX developments and applications. So, Florian, it's a pleasure having you. The floor is yours. Thank you.
Francisco, thank you very much for that kind introduction. It's actually a pleasure and an honor to be co-host in this panel with IRENA. However, the interesting things are those that will be said by the panel and not by me. Therefore, I would like to quickly introduce the panel and would ask you to take your seats up front. You don't have necessarily to sit underneath here.
But it's better, it's better.
Okay, the first one will be Lars Boerger. He is currently Vice President Strategy and Long-Term Development for Renewable Polymers and Chemicals in Neste, a Finnish company. Please.
Should be challenging for the audience.
Okay, so maybe everyone away. Okay, the second person I would like to introduce into the panel is Rosella. She's the head of opportunity analysis and strategy report at Versalis-ENI. Welcome. Then I would like to ask Dharik Mallapragada to join the panel. He's a principal research scientist from DC-Muse at MIT Energy Initiative. Next one would be Martijn de Graaff, program director for petrochemicals and Voltachem at TMO. And last but not least, Joerg, Unger, senior vice president, low carbon emissions and projects at BASF. Okay, I guess we're going to check out. So, thank you very much for you in the audience and you on the panel to join today's discussion. We've already heard a quick introduction, and one thing we discussed in this panel before in our pre-meetings was how do we actually see the term decarbonization. And one of the things in this industry is we prefer to talk about defossilization because carbon is one of our main building blocks that we will need. However, we will discuss this issue a bit further now. As already mentioned by Francisco, the chemical industry is one of the hardest to abate, partly because it has a high demand of energy in itself, but also because it has a carbon feedstock, which currently is based on fossil fuels, essentially. So, just to give us an idea of how big we see that challenge, maybe Joerg, you might want to give us a start from a globally active company. How do you see the time perspective and how do you see the challenge?
Good, that's an easy question. Thank you for that. No, first of all, I think we have to look where we are today, and then we have to think about where do we want to be in 2050. And I think it's very easy to agree on where we want to be in 2050. In 2050 we want to be in a circular economy that really keeps carbon in the loop, we avoid carbon leakage, we don't have to decarbonize, but we have to use it more wisely. We agree to all that. We have to use renewable energy, because in our case about 80% of our CO2 emissions are due to the energy that we need to drive our processes. So we all agree on that. The big question is, how do we get there? And this is also the topic you mentioned already. We have the assets that we have today. And so has the energy industry. And what really is changing a lot more is the context in which we operate. It's not so much the content. We will continue to have carbon going forward, but we have to use it more wisely. And we have the issue that the energy side is changing a lot. We have now fluctuating supply, which we're not used to. Our raw materials and energy sources in the past were all continuous. So we have big plants that run continuously. Now with fluctuating energy, this is more difficult. So we have to adapt on our end, flexibilize our plants, if possible. That's probably an innovation piece. But also the energy sector has to do its piece, because we have to work this topic from both ends. We have a supply side and we have the demand side, and then we have to see how do we make this match, because the fundamental structure of the supply side is changing a lot. And now we on the demand side also have to move. So this is the fundamental challenge. We can do a lot with existing technology. I don't think we need fundamentally new technology, but we have to deploy it in a different context. So we can be relatively fast, water electrolysis, we try electrification, but we also have to do this always in an integrated system. So we need a systemic approach. The industry alone cannot do it, the energy supply alone cannot do it, the connectivity between the two of them. This is the challenge that we face.
Maybe Lars, you want to add on that?
Yeah, of course, full agreement. So very important, as you mentioned already, to differentiate between the energy which is used for the chemistry and the chemistry itself. So really the map. It's surprisingly complicated for people to understand that what we touch is mostly carbon, that chemistry is carbon, that we are producing materials, and those are made of carbon if they're not from metal. So this needs to be answered first of all. So that means automatically that besides doing decarbonization of energy, we need to change the carbon source. Just to repeat that, there are only 3 principal sources for that. And that is from the bio, from the techno, and from the atmosphere. So that is technosphere, so the recycling. That is of course, no matter what scenario you look at, the recycling rate needs to go up. You need to take the carbon which is already there and need to recycle that mechanically or chemically. These are the things which we will work on. Then we talk about atmosphere, that is power to X, that's a big topic, we probably touched that several times again, and biosphere. And then we have been discussing that as well. In the end, carbon from biosphere and from atmosphere are identical. It's just actually the competition between nature and us, who's more efficient in kind of doing the trick. And well, efficiency already is won by the human race, if you like so, but still plants are really very good because they have some features. They actually most of the times grow for free and so on. That's also why at our company in Neste we're focused very much on bio-waste, waste and residue, because there we have the carbon already in a format which can be used more easily. And we've used the plants to reduce CO2 into something which is usable. So this is a story around it, sorry for that. So how does it look like? There's whatever, 50 different studies how the future could look like, but in all cases, I think, there is a chance to decarbonize, to change to a chemistry which is free of fresh fossil. But also the effort for that and the energy usage is really high, and we've seen that in the downstairs section. This is a really challenging thing. But there's possibilities if we are not blindly only following one step. I think that is also important. Because too often people think they want to go for one solution, and it's really as boring as it is. We need all these solutions, and then that would be my statement on that.
No silver bullet. That's a shame. No silver bullet. But maybe Martijn, your take on it?
Yeah, maybe I want to add something. So, okay, the chemical industry part has become part of the problem, but I think more importantly is to stress that it's a big part of the solution. And if you think about the chemical industry, the system, what is its role? Its role is to convert feedstock with energy to useful products for society. So why can the chemical industry not make the new useful products for society, mobility, the materials that we need, food that we need, using renewable feedstock and renewable energy? This is the transition we need from the old energy, the old feedstock, towards renewable energy and renewable feedstock. And I think we can manage, we just have to work on it and make the right portfolio decisions.
Surprisingly, windmills are made from chemistry, by the way.
There's really a lot of skills and chemistry to build our renewable energy sources. But Rosella, how do you see the importance of recycling and how will it develop? And maybe especially because we might have a few decision makers in the room as well, what role does regulation play on that?
I think that recycling, as you mentioned, is a way to storage carbon inside the production chain of chemical industry. We have that carbon available in plastic waste, so using carbon help to decrease use of fossil feedstock and at the same way prevent that carbon to be released in the atmosphere CO2. So we see a double advantage on that side. We really believe in complementary solution in recycling, such as like a chemical and mechanical, because chemical recycling allows to treat also those plastic waste that is non-mechanical recyclable, and we are also a matter of quality of the final product. Mechanical recycling has some limits in application that are the most demanding and regulated, such as food contact, one application. So with chemical recycling, we really can wide portfolio of type of plastics that can be recycled, but also application that we can provide to the market, to the end user market. I think that in Europe we already are very good at recycling through mechanical processes. We really need to bring these processes to another level to add capacity and to develop chemical recycling plants. Currently, the technology stage is in pilot demonstration stage still, but the chemical industry is very committed and many new capacities we announced. So by 2030, we think that this technology will be at scale, at industrial scale. From a policy and regulatory point of view, I think that what we are still waiting for is something that really has the potential to boost demand. Because, for example, in Europe we have targets on recycling of plastics, but on the other side, when we have recycled products, we need someone to buy them. So in that sense, we really need that the demand to be strengthened. We can do that by, for example, sustaining demand. We saw already in other sector that policy framework really helped. We can see in renewable energy production, for example. So I think that it is a very little step that can really support the end user market to provide. Right now, there is no advantage, really concrete advantage for end users to buy sustainable products in terms of products that contains recycled content or bio content too. And the development of regulation is going that direction. For example, we have regulation on packaging that is defining minimum recycled content. That is important. That is a measure that really can help. But we really need inside this framework that all recycling technology are recognized as viable, and as chemical recycling leverages existing assets to provide recycled content to final product, we need also a framework to recognize the methodology to count that sustainable content inside the final products.
Thank you very much. Dharik, maybe how would you see the role of recycling in the chemical industry in the future, especially with respect to the energy demand that comes from it? Is it complementary? Is it something completely different? How do we have to approach it?
Yeah, so I think first thing I'll say is that I think we all agree sort of on the end scale. One thing I perhaps challenge the panel here is that, when we are sort of talking about an exponentially growing industry, I think Francisco in his slide highlighted, 70% growth in just the final products. Recycling can help you, but it's not going to kind of, you need virgin feedstock to come into the system. And, as having worked a lot in the area of biomass, and a lot of our chemical products are oxygenated products, I'm all for thinking about, bio-based feedstocks, but the reality is, you're going to have a lot of pressure on other sectors of the economy wanting the same bio feedstocks. So I think, to me, just being realistic, I think we have to think about the energy component component of this puzzle and the feedstock component of this puzzle is sort of a staged process where perhaps we can get new technology with new feedstocks on board, but I think we have to simultaneously focus on, we have all this new infrastructure, manufacturing capacity, you know, that has been deployed in the US over the last 10 years in other places, which is going to be around in 2050, right? And it's going to be a large portion of that demand. We're likely going to build more plants in the next decade with the existing technology. And so I think thinking about the energy component and the sort of feedstock component as perhaps two separate problems in the short term, I think will help us focus on solving the energy problem, but then the feedstock problem, you know, kind of comes along. And I think your question around recycling, you know, that many of the crackers in the US are set up to, you know, switch from, I think, to naphtha. They've sort of learned the hard way to do it. Now they've sort of do it. They're also sort of in a position to get, you know, the bio crude, you know, that you can produce from some of these, you know, recycled products. So I think if you have a volume that emerges for that, you can pretty easily integrate it into the existing system. But I would say, to me, like, the feedstock problem is important, particularly for new technologies and greenfield manufacturing. But one of the things we are really focused on is trying to sort of understand, break down this barrier between how industry thinks about energy procurement, what are the options versus how the energy system is ready to provide that kind of clean energy.
You know it, right? I mean, first of all, yes, I mean, there's no scenario where you can circle completely. So this is just a fact. And you can pick the number. If it's a chemical recycling, maybe you can, at best, 70% of carbon circulating. You need to have only 30%. Realistically, it's much lower. So you will always need virgin. That's a matter of fact. But I would just like to also to broaden, let's say, the view. It's not necessarily so that you always need extremely high energy to make biomass available. And that's an example which INI does, which we do, where we use oils and fats, which have a carbon to oxygen, sorry for the chemical part, ratio with relatively little oxygen, so you don't have to reduce so much anymore. Your pure carbon, those you can use as drop-in. And that's another point that Joerg already mentioned. We will simply not be able to build all this new. I mean, we've heard now how much steel is used for the electricity, so nothing left for chemistry probably. So we need to use the existing plants in the existing chemistry, which is very efficient, and just do drop-in solutions where we then change the feedstock, and we can then continue, and we need to work on the recycling of it. And in the feedstock, we can do that. Also, not always with only extremely high energy efficiency. Actually, our refineries are lower energy usage than classical refineries, the biorefineries. So that's also existing. Is it sufficient? Good question.
Maybe.
You're right.
I think also for this audience, because you asked this, Florian, explicitly, what is the message to more policymakers, governments, and these kind of topics? I think a message that you really have to set this through a little bit also my initial statement. We have now costs coming into our industry system that has not been there before. This is first of all, I mean, we mentioned a little bit, we have now a fluctuating renewable energy source, so there is cost associated to kind of smoothen this out, because if you don't smoothen it, our grid expansions will be huge, because the size of the grid is determined by the peak load, not by the average load. So that's one thing. So we have costs, and this is sort of from our industry's perspective, storage of energy is inventory. That's bad costs. It's sitting around doing nothing, but still you have to invest in a battery. So cost is coming in here. Second, also, if we don't do recycling, then we can just discharge it as an incineration CO2 into the atmosphere so far at no cost. Now, emission trading is coming in, so this cost is coming in, but this cost is also entering into the balance sheet of the entire industry chain, not of individual companies. No, entire change societies have to bear their costs. So first message is inflation is likely to stay for this reason. Second is, and this is also a little bit in the direction of how do we do this, because if you go for alternative technologies, or if you go for alternative setups, there will be more costs, so you will be less competitive. So the one who moves first is the first one to go out of business. And this is something for the regulators. And looking specifically into the competition law, a lot of our funding today is driven by competition law. It's not by fostering something, it's by basically avoiding unfair competition. But what we need here, we need unfair competition. You have to foster fast movers to
basically create these shining examples where people say, yes, it's possible, yes, there is a market, yes, you can do it. Everybody's sitting around waiting for green premiums. There will not be a green premium unless we have a green product. So this is this chicken and egg thing. So I think this is something that, as a message also here, you have to probably foster unfair competition.
Okay, that's a strong message for consumers. I'm not sure how to avoid just getting into a subsidy race between different regions if you go for unfair competition. However, I would like to go back to the comment that Lars made, and would like to question whether that was not a very European perspective, because the growth that was mentioned by Francisco will happen mostly outside of Europe. It will be in Asia, maybe in the US or in the Pacific. So we will face in Europe a shrinking industry, or at least a stagnant industry to that extent, trying to make a change. That means using the existing assets, existing plants, while if China, let's say, for the sake of the argument, would like to make the change, they can just build in a new plant with all the new technology. So how do we see that competition, this unfair competition, developing in that sense? Maybe you have Martijn.
Yeah, I think it's a very relevant point, and if you look, it's already happening. And so it's already happening that commodity production is actually moving towards the low-cost energy and feedstock side, which has happened already before, right? So the question is, what will also our industry look like in, let's say, 20 years? And it might well be that commodity products, like intermediates, like methanol or ammonia, was already mentioned also for the fuel sector, will be produced somewhere else, and that will import these molecules and make higher added value products out of that, for example, methanol to olefins here in the region. But this will mean that the commodity production will shrink, and maybe specialty production, which is closely related to the specific needs of a region, will grow.
Yeah, nothing to disagree with, not too much. But of course, I mean, one aspect is, obviously, if you talk about, and you have to rethink it also, if you talk about circles, you have to think in circles, and this means also that where consumption is, there's a need to close the loop. And this is what we also see. This is what I feel a super interesting development that, I don't know if there's a representative of a company like Lidl or Graaff, which is a retailer, is becoming a waste handler, is building a paper plant. That shows that this waste, which we talked about, is a source, it's recognized. The ownership of waste is a fundamental topic. And that would mean that there's besides that, also bigger trends. Of course, with the majority of people living in Asia, that holds true for that as well. So that was one of the comments there. The other one is
I was just going to mention that, unlike energy production, for other processes, we're also talking about raw material here. So if you look at, there's already differentiated raw materials and different components. I think that continues to sort of remain. And so ultimately, I think the sort of regional dominance is going to be a function of, we have access to energy, but we also have access to the feedstock. Right? And I think this is a very US perspective, but I think I don't see any regulations in the US reducing the production of natural gas liquids in the near to medium term. If anything, they might increase. So I think from a feedstock perspective, the US will have some advantages now, whether you have the energy component that comes along with it, that's highly debatable, but I think that ultimately will determine which direction you go, and I think advantage, there's very few other regions in the world that have that kind of stuff. There's even the Chinese example, you're talking about coal, but then what is the carbon intensity of that product, and will that be something that Europe is willing to import, right, as a commodity, that's just exporting your emissions at that point, right? So that becomes a challenge.
Now, the comment you said on the European centristic view, of course, China, if we take that example, could build a new plant, new technology, but honestly spoken, also, how much new technology is there for polyethylene? Or is it optimized already? So is that really something which will change the needle? If you assume that the actual innovation in chemistry, the most important innovation, is actually on the sustainability of the carbon source, it's not necessarily the most important innovation on a new functionality. I'm daring to say this. And as we need that as well, blah, blah, but the majority of things are there.
Maybe this is the point to build on this unfair competition. Because yeah, and we have to, I think we have to appreciate that the products we're making today, the products we will likely have in 2050, will not be very different. So we basically have to make the same products, but in a different way. And in order to make them in a different way, we have to deploy technologies which today are not competitive with the, let's say, the dinosaur technologies that we use based on fossil raw materials. They are very much optimized, they are very efficient, and they are very hard to beat. And this is what I meant by unfair competition. Then you have to say, I help somebody who moves early to survive this early move. But I only support the early mover. To put down a flag and say, okay, you have the new product, you have took the cycles, you took the risk, so you can run first, and all the others have to follow. This is what I meant. I'm not an advocate of unfair competition in general, but in order to get things going, there is nothing more effective than peer pressure. So competition law has to really help to foster peer pressure. That's probably a politically more correct term than saying unfair competition. So this was my point.
Avoiding a first mover disadvantage, that would probably be the appropriate way.
But then
Still the same.
Coming back on the global perspective, and Joerg, I'm afraid you will have to answer that question. Considering that your company is globally active and probably ships quite a few things back and forth around the globe, is this not just, let's say, an optimization question to get the cheap energy, let's say, from the Middle East, and at some point ship some intermediate somewhere else for final production, and then maybe being close to whatever your final market is, have enough specialty chemical coming out of that? Or is it really that you say, okay, we as a company have a global responsibility and we don't take, let's say, the easy ways out, but we have a standard that we want to implement globally for our company, and hopefully the other companies will follow?
No, first of all, I think that our targets are global and the way we operate are the same around the globe. So that's clear. So our target that we have is reduction targets 2030 minus 25% of our emissions and 2050 carbon neutral is a global target. So we are not bargaining on that. So that's very clear. So the issues that we have are the same everywhere because the technology, the physics, the chemistry is the same everywhere. So that's number one. But we always also have the approach, and you see this also in our activities, that we drive towards local production for local consumption. So this is very long, this is not changing. And even in a world that is more sustainable, you have to avoid transportation wherever possible, because transportation per se does not create value. It takes energy. So you have to do this smart. The big question is, at what stage in the value chain do you do the transportation? Because, and this is also no different from the past. In the past also, we did not have a lot of oil and gas in the industry centers where we consumed typically, specifically in Europe, but also not in China. A little bit different in the US. If you go to the Gulf Coast, there they have the oil and gas wells, but also the processing. But in many other regions, we always have this pattern that we have to import raw materials and we have to import energy. Well, the sources are changing now. In former days, we imported in Europe natural gas from Russia, which is more difficult and not possible at the moment. So new renewable energy from the Scandinavian countries come in. So this is changing, but in essence, the general pattern is the same. No fundamental change. So as I said, global targets, yes. Global standards, yes. Local production for local consumption, as always. So we just have to adapt it to this change in the context, as I said, energy coming now from green energy sources in Scandinavia, natural gas from Russia, or Chile, Australia, play a different role. But in essence, if you look at the Middle East, they have it again.
Actually, I would like to challenge your statement on the profits of the stay the same. Isn't it so that towards the future there might be a change in balance between polyesters and polyolefins? Because polyolefins are based on fossil, which doesn't contain oxygen. Polyesters you can make from oxygen-containing feedstock like biomass and or CO2, and polyesters are much better recyclable.
First of all, this is not contradicting my statement because polyesters we have today and polyolefins we also have today. So that's not, so the balance could change. So that you say basically the most durable plastics you really only use for the very durable demand topics for high temperature applications and so forth. By the way, the recyclability of polyolefins is very good because you only have hydrocarbons they're going around, and the big topic in this, and you can use the existing acid base. The big topic in all plastics is mostly not the matrix. It is the additives, colors, and all these kind of things, and this doesn't change. But I think that there can be a discussion what kind of plastics you use in which application. But the recyclability of polyolefins is quite good. I would call it the gourmet plastics for recycling because it's only carbon and hydrogen. And polyesters already you have some oxygen in there, and petrochemical people don't like oxygen.
I know. That's why.
I think there's no need to get rid of any plastics as long as we can recycle them. So I don't want to make any, programs on this. We are mainly regional business focused in Europe. So what can I say is that for sure Europe is a region in which we have some scarcity of resources. So recycling and biomass can really actually have some kind of geographical area to be always less independent from import of resources and can really have to use our own resources. In terms of waste, what is really need to do to support the increasing volumes of recycling capacity is to strengthen infrastructure for collecting, sorting of plastics. This is something that is very variable in all the regions of the world. So we think that the main recycling rate for plastic waste at global level is like 10%, while in Europe is like 35, and if you look at packaging, it rises up to 46, so we are pretty good at doing it. We need offshore to strengthen, to find new efficient way to collect and separate plastics, and these are circular models that can be then exported and applied in every region, but it's really a fundamental gap in scaling up recycling capacity for sure.
Maybe you can comment a little bit on, let's say, the cultural observation that I made when talking to the waste industry. They have a completely different mindset than the chemical industry. For them, they have to get rid of stuff, and they get paid to get rid of stuff, so to speak. And if you talk about using waste for plastics in the future, we need to work together with that industry and change their mindset to say, look, this waste that you collected here is actually a valuable feedstock, and we would like you to collect it as clean as possible and so on in order for us to use it. How was your experience with the waste industry?
I think that in partnership in the value chain about these topics are really important. We are seeing that all chemical players that are engaged in recycling are making partnership upstream with the supply chain to secure supply of quantity and proper quality of feedstock. That has to be suitable for the recycling technology. Of course, innovation in technology for recycling is still ongoing, so we are able to process like new types of plastic that maybe before we could not. And also downstream with end user industry. This kind of strategy is helping the industry to set up the circular business model to de-risk investment, to secure takeoff or production, even in an environment in which there is no advantage, as I said before, in supplying circular products, but of the commitment of brand owners and industries to really so good the level of carbon footprint.
Yeah, just exactly, I can only agree. Just one thing I wanted to confirm what you said that's really interesting. It's a clash of culture, you can say. So we see that in projects which we have been doing where just one thing to illustrate that is where the different safety cultures which come together. So if you have a mechanical recycling company which you want to work with, and you're coming from a refinery or petrochemical background, you really have very, very, very different opinions about how safe such a thing should be. But also to make that that it's also really a complicated effect, because the safety which we are installing is necessary and so on, no compromise, but also very expensive. And probably all things accepted too expensive. So this is one of the parts which you need to tackle as well. Just besides all the other important topics. Again, we hear about also the cascades, so really polyesters for chemical recycling, pyrolysis are not really, we don't like that. Yes, we like pure, but for other chemical recycling, it's the best. So here again, it's unfortunately extremely complicated. So the solution, as you say, is kind of mechanical recycling where possible. And there's different cascades of chemical recycling. And in the end, also something hardly ever said, but if it was a bio-based or power to X molecule, then incineration is not that bad anymore. Yeah, because you generate the energy, so CO2 you reduce, plus it is not adding CO2. And ultimately, today, if you're realistic, everything is incinerated. I mean, this is the percentage of recycling is ridiculous, I dare to say. So, recycling is not that aspect. Yes, it's, in the end, sorry, if we have this circle of 70% which can be recycled, we have to add 30% bio-based one or the other way. You can calculate, in a few years, you only have bio-based anyway. So,
I just put everything in the landfill and in the ocean, not inside. I mean, you mentioned everything is needed and clarified, nothing is collected, that's the majority of the and then there's a minority that is collected, and then some of that is
goes to the ocean, yeah.
So I think they have a collection problem, but at least we are resolving it.
I think that once that the plastic waste will get, I think that once that plastic waste will get higher value, it will be thrown away in the ocean because people would need it to, it would be profitable to collect it.
Yeah, but I think also here is this need for a systemic approach. So and you really have to look at it from the perspective of net zero carbon leakage. So because if you throw your bottles into the ocean, it's a carbon leakage.
Yeah.
It's used. So we have to start there. But then if you go to the recycling, because you asked this question, how about, I call it the recycling industry, if you look at them, they have different mindset. Their mindset starts basically with how they collect things. They collect things according to the last use of these pieces. So they have automotive residues, they have residues from packaging, they have residues from electronic devices, so they are basically coming from the end-use perspective. But this is not necessarily what we need. We need a chemicals-oriented recycling because we have different plastics in automotive applications. So we have polyolefins, we have polyamides, we have polyurethanes. Doesn't matter that it was in a car, but if we want to use it chemically, we have to know what it is chemically. So we have to work with them to achieve a chemicals-oriented recycling, and we're doing that. And second is also the mindset from a business model perspective is very different in the recycling industry. We typically, as chemical companies, we do synthetic chemistry. So we have raw materials and we bake like a bakery. We have and we make something out of flour. Yeah? So we do this and we synthesize it. The recycling industry is a destructive industry. So they have something and they have to chop it into pieces. So this is a very different approach, and you can see this in the business model. We are very much trained to, the more of the raw material we put into our products, the better the yield, the better our results. In the recycling industry, this is the opposite. The more waste they process, the better for them. So the worse their yield, because they can only make the same energy typically in that plant, the better their profits, because they get a gate fee. This was completely new for us, and it's these simple things, so they think differently. They like bad yields. We hate bad yields. And you have to go across them. Yeah?
I think that's quite useful insight on but what you said before, that we have one industry which works at the end-use part and really collects, and we would start at the very beginning and kind of like replace our feedstock. And this is where we need to close the loop, essentially. Therefore, we need to engage strongly with the waste and recycling industry in order to get as much of the carbon as we can and to keep it into the loop. Yeah, I wanted to change to the question that has already arisen before, how to adapt to new energy sources. So currently our energy sources, gas, oil, electricity, they're continuous. And we don't have any problem whatsoever with them. And we have a lot of questions. Okay. I think first we start with the energy sources. So we could easily imagine building a new plant under the conditions of an intermittent energy, but it's much more difficult to imagine the existing plants being adapted to intermittent and fluctuating energy. So how do you see the, let's say, greenfield, brownfield advantage, disadvantage developing? Well,
so I can start by, so we've been looking at, I think tracking and those processes, not just to give some scale context. I'm sure the audience will understand here very well. 1 million ton per year ethylene facility will consume about 500 megawatts of power ballpark. Right? So you cannot, thinking about turning up and down a facility from 0 to 500 megawatts, that's just not realistic. But I think one thing you can think about is that these facilities tend to be clusters. So you already mentioned the Gulf Coast, where there's approximately about 4 gigawatts of generation capacity today, mostly heat and power facilities that are already existing. So if you imagine that kind of a cluster existing, you can imagine even if 10% of that facility can be sort of turned on, they're offering a lot of flexibility services. So when we had the winter freeze in Texas a couple of years ago, there was a blackout. Imagine the kind of money the chemical industry would have been able to make by selling 10% of their power. They did not have a feedstock at that point because the natural gas pipeline also got froze. So there was a case that could have been made where your ability to be able to turn down and not consume at peak points, even 10-20%, right? And I think 10-20% is very achievable in the near term. Could be enormous because they tend to be clustered as very large consumers.
Okay, but that would be saying, okay, you just turn the industry on and when prices are expensive. However, since the energy-intensive parts of the chemical industry, or in this case electricity-intensive, for example, happens right at the beginning. These are the very emission and energy-intensive steps, and these steps then feed into the value chain. So whenever we shut down at the very beginning, we are not only losing the money from producing olefins or whatever we had produced, but we are shutting down the whole value chain. So the actual economic loss is much more than just the loss of that small capital. It's a loss of all the added value that we would otherwise have. And the question for me is, how do we balance that? Martijn?
Yeah, so maybe I've been in so many discussions where this is actually still the problem, and it's about energy storage. Wherever energy or molecule storage, wherever in the value chain, and who is willing to pay for that? And so it's the electricity people saying, you have to absorb our fluctuating electricity, otherwise we don't have a business case. And it's the chemical industry saying, we need baseload, otherwise we don't have a business case. I think in the end, this will just add to the cost and you have translated to the end product. Only then you're able to finance this problem. You still have to find the solutions, but only then you're able to finance the gap. Another thing that I want to say is what I'm seeing nowadays a lot is these industrial parks thinking about small-scale modular reactors, nuclear reactors, to at least have some level of base load in the changing grid mix that is really going to be a challenge here.
Maybe to your question, what do we do with our existing assets now? Do we tear them down? Do we build them in other places? There's also a discussion down there. I think it's about a balance, it's about a mix. You saw we are investing in electrified steam cracking now. Cracking furnaces, high temperature heat. High temperature heat normally is not the best thing you use electricity for. Normally it's better to use electricity to really make mechanical energy. Exergy is the end, engineers typically say. So that's one way. So the question is, where do you put your electricity in your existing plants? And to what extent are you electrifying? Because what we also saw when we looked at our electric reactors, and in fact we did this together with an industry initiative and together with AFRIC, which some of you might know, we did a simulation also of the European grid. If we would electrify 10 crackers in Europe, they would need the same energy as the entire country of Belgium consumes in 1 year as electricity. And what we also learned is the more we require a flat profile of our supply, the higher our carbon footprint. because you need a lot of whatever natural gas-based or fired energy sources to really ensure that you are really having this bad design. So for us, the combination, and this is an advantage now of crackers. Crackers typically where the energy goes are the furnaces. And these are modular pieces anyway. So a large cracker has 10 to 15 furnaces. So I can basically go with a hybrid system, at least in the transient phase. What I can do, I electrify 2 or 3 of my furnaces. It's not as tough on liquid. But I have some fluctuation because I can basically, like in a hybrid car, I can balance what rates I run. The caveat that comes with that, the utilization of my separation plant, which is the capital intensive piece, is not at 100% or 95%, which we usually run for. And this is then a discussion also with the finance industry. Our profitability will be hampered by that. But we are helping the energy industry because they don't have to invest in storage because we have this resilience. And I think here you can see it's all about how do we create new business models. It's not the technology, it's the way we do our business. This is why I said before, the context is changing, therefore our business models have to change. Don't have too much hope on the wonderful new technology, except for one thing, fusion.
Maybe, if you allow me to again, not contradict, unfortunately, it would be more interesting if it would be contradictionary, I guess, but cannot. But then, maybe a bit to the different component. I mean, one thing is, of course, biomass is also something that can produce data. That is something which should not be underestimated. Somehow it's taken away outside too often. Of course, you have to take care of the food versus feed and so on, but in principle, it can handle that. And that's an important aspect to not content. The other thing, a little bit contradictory to what I said earlier, of course, if you look into biotechnology typically operates at lower temperatures. So it's per se more energy efficient. And that is also, of course, a way out for several opportunities, specifically for chemical species which are already capable of oxygen because they're able to full production and so on. So that will also be part of the mix, this technology on a lower energy scale.
And maybe I want to add to that because I work in Voltachem, so we also try to work on breakthrough technologies. Yes, you're right. For the next 20 years or so, we will need the current technologies there. We just have to build them, we have to find the new business models. But what you're saying, if we can cope with having lower temperature processes, and that's either bio-based or electrochemical, what we are working a lot on, then you need much less energy for doing these transformations that the chemical industry needs to do. And then energy efficiency goes up. The only thing is that these technologies are still at this scale, So you have to develop them further in the, let's say, next 20 to 30 years, tapping into the learnings from the hydrogen domain, because the hydrogen domain we already learn to go to gigawatt scales. If we can use these electrochemical processes in the future, 2040 and beyond, then I think we can make a next step in the production of these oxygenated molecules and maybe even the olefins.
I just mentioned that, as a researcher, we're also looking a lot at chemical technologies as a mechanism to sort of enhance process flexibility. But I would argue that I think for the existing manufacturing capability, there's also perhaps a mindset change both on the electrical grid side, but also on the chemical industry side that needs to happen. Chemical plants are so used to operating like islands, no access to external energy, and the question we get often when we talk to industry folks is, we're connecting to the grid, but the grid isn't reliable, at least in the US, there are a few problems recently. So, what's the guarantee that you're just kind of, getting that cascaded effect? So I think there's a cultural mindset where you need forums where you have the utility industry and the chemical industry sort of talking to each other. I'll give you one example. I don't know how big Bitcoin is in Europe, but Bitcoin is very big in Texas, and they're installing all these Bitcoin farms, in places where electricity prices are, fluctuating so dramatically, and they're making a killing, basically, running these operations. So it's a different industry, it's a different process. We don't have the same kind of flexibility in chemicals, but it just gives you an indication that I think the process flexibility is always not a bad thing, and it's about the margin of arbitrage. If you have enough arbitrage, all the flexibility can be good.
I think that's a fair point, but you have to keep in mind that in the chemical industry, if you have processes which run at a high temperature and you change suddenly something, you have mechanical stress and the whole thing goes down. And that would be a difference to the Bitcoin mining, which I think safety still needs to be paramount in whatever we do. I think that is okay.
Yeah, maybe I want to add, so because you're saying Bitcoin mining, I think, well, there will be huge competition for renewable electrons. And we're not talking about the chemical industry, but there's these competitors. We also see it in the Netherlands, so the data centers, they take the electrons right now. So there needs to be some kind of prioritization or merit order in what we allow these electrons to go into. And what do we value as a society? Do we value the bitcoins, or do we value products that we can use to make more sustainable? I think that's a higher level discussion that's not really happening.
Since you just mentioned that Belgium will be this 10, I mean, the number is outdated, somebody has probably better number, but it was Denmark 2 years ago, which was the total Bitcoin consumption. So that's more or less the same size, so that's the question, do you rather want to have the furnaces being run on 20 or Bitcoins? My choice is clear.
I can also remember the saying that the Ludwigshafen from the BASF had an energy demand like Denmark. So it gives the overall perspective is huge. But maybe we return to some of these questions from the audience. We can start with the first one, so that anyone of you can easily read it. Which would be more promising to produce high temperature heat in petrochemicals? Hydrogen or electricity? What would be the preferred option? What would be promising? Both on technical side, but maybe that's not it.
Yeah, if I have one word, then it's both. Because, and that's exactly, but I mean, the big question is, do you really need these high temperature processes? I think this is where we have to start with. So are we electrifying something which we should not do in the first place, or could do differently by bio-based processes? Now we can have a debate on the energy intensity of bio-based processes, if we talk about water distillation, things like that. So we will go back to Exergy and we discuss. Anyway, so, but I think both. Because you could, for instance, use electricity with highly efficient heat pumps. You can go up to 200, 300 degrees C, and then basically do the rest with hydrogen. So I think in these hybrid solutions, in this resilient system, so this is where the solution is. There is not, we had the discussion prior, is it now alkaline electrolysis or PEM electrolysis? The answer was very diplomatic, it's also both. It depends on the application case. So, and I think this is what we have to learn. There is not black and white. It's about finding the right balance and adapting it to the local opportunities and local needs. That is the way. And we have also a big discussion always technology openness, and not everything fits everywhere. Yeah. So both.
Martijn, your take on that one?
Yeah, it's very generally stated hydrogen, so it's also dependent on the source of the hydrogen. So if you use power to hydrogen, it will be different than if you use other types of hydrogen. But if you want to go to very high temperatures, I agree that hydrogen is the right choice. The question is, where will it be coming from?
If I just want to highlight that most crackers could actually make hydrogen today. So hydrogen in some contexts, at least in the US setting, is sometimes seen as a problem rather than feedstock. So you can imagine a scenario where you can use it within the facility, reform it, take the hydrogen on site, and sort of close the loop by doing sequestration. That's another solution here.
Yeah, maybe added to that, so there was a whole discussion in the Netherlands about the color of the hydrogen that comes out of existing processes, and that relates actually to legislation. And so what is the carbon intensity of your hydrogen that you use?
Yes, I mean that's you referring to the RED 3 regulation, which is a very difficult one. And I think the question that you have to ask maybe goes back to what Lars said. You have to ask where the carbon came from. So if you have a bio-based carbon, this is maybe a different story than if you have a fossil-based carbon. How you deal with also the hydrogen generation, because indeed, I deliberately did not say that the hydrogen would come from if we fire a cracker. It could come from different sources. It could come from electrolysis. It could help then also to balance the grid, because we can run the electrolysis then in a flexible way and run it for some period of time. I wouldn't run an entire cracker on electrolysis hydrogen, at least not for a long time commercially. But you can use your methane sources and basically decarbonize the methane and use the hydrogen. But again, there is a lot of, the technology is there. We have to apply it in a different fashion. So again,
yeah, I think there's not too much disagreement on the panel on this one. However, the next one might be interesting. The decarbonization costs and how do we get it through the value chain, so to speak. The example of steel is often mentioned in the sense that, while a car has maybe 1,000 euros worth of steel in it, and if the steel is twice as expensive, the value of the car just increases by 1,000 euros. However, at least anecdotally, I had a similar discussion with the ammonia producers last year. And what we actually saw that part of the inflation we had in Europe this spring was due to the rise in fertilizer prices that happened in the autumn, winter, because the farmers didn't want to pay the high prices when it first came. Prices rose even higher and farmers had to buy. Food got much, much more expensive. So, how is your take on how the increase of the final product in price would be, considering that whatever chemicals or steel or whatever is formally just a small part, but it might rise significantly there?
Yeah, I think you have to really tackle it from an end-to-end perspective. So all the way down to end consumer products, because as you said for cars, we also did this analysis for other applications like home care, personal care, even food. Typically, if you really decarbonize, I shouldn't say decarbonize, if you reduce carbon leakage along the entire value chain, typically your consumer end prices, they go up by 3 to 5%, maybe 10, but not 100, 200, 300. But if you look at it on a level of certain parts of the value chain, this can be significant price increases. And the way we have organized our value chains in the past 20 to 30 years is very tailoristic. So it's only a discussion between your supplier and your next customer, supplier and next customer, supplier. So if we want to unlock that, we have to go through things which have been done. For example, maybe some of you know the First Mover Coalition, which Mr. Kerry is supporting a lot. And there is also a study by, I think it was by Boston Consulting a few years ago, where they called it the Supply Chain Challenge. And they really looked at the textile value chain, food value chain, consumer goods value chain. They really also confirmed what I just said. It's 3 to 5%. So from an end consumer sphere, this is not justified, but the industry doesn't recognize it.
No, I would say that for sure, first of steel just rise, but that's all kind of technology. So if you want to apply traditionals, if you want to apply a new technology, for sure sustainability is very intensive, and for chemical industry that is traditionally based on high-scale plants, it's still very important, this aspect. I think that the support of public financing and also private and public agreements for doing some, support, economical support, kind of support is very important. I think that something is already going on in Europe. We have some kind of financial innovations and technology to be scaled up from demonstration to commercial size. But of course, I think that what is not something that no one of us wants is that the price has been paid from final consumers. So we need to have models that internalize value of sustainability without making it pay from people, because demand and demand of the market is something that really drives innovation. So it's something that we need to address.
Now we can contradict, yeah. I think it's fair to say, I mean, as much as it's right, the analysis, the end product, the increase is really low. Also today, with existing technologies, we have done the example for diapers, and the per diaper was 0.3 cents or something. So you could argue if keep the planet going or pay more for 0.3 for the diaper should probably make the right choice. But effectively, it's getting more expensive. And the effect of what we are having, all these issues we're having, is simply the simple fact that the costs of this cheap carbon have not been externalized, and they need to be internalized to a certain degree. We see it now, we see it as an increase of bio-based, but effectively it's just compensating for the too low price which we had. And that goes along with that the lifestyle we had was too cheap. That's also part of the truth. There's a social aspect, but I don't think we can 100% offer that. I don't think it's realistic to say that. I don't think it's fair to say that. And if you allow me to take the example of Venice. Venice now has an entrance fee. And if you say there cannot be 2 billion people going to Venice, then there's only 2 ways to handle this. One is to put on a quota, and you say, okay, there's every year, whatever, 100,000 for Germany, 20,000, no, sorry, 25,000 from the Netherlands, so 1 quarter, and so on. This is a quota, or you put it by price, and you say, well, it costs 1,000 euros just to enter Venice. And one or the other way this happens, so I'm afraid.
If you want to bring on a global scale sustainability, you have to consider that someone could not afford to pay that price. So as long as this model goes to a higher level, we need to reduce this gap and to let everyone can afford sustainable products. So it means that it's going to take time. It's not like for tomorrow. That's for sure. But you cannot say like Venice is for tourists that can afford to go to Venice.
Of course you're right, but I think this is a political discussion between the balance between that. I think there is something.
That's why the politics can really do something and really impact a lot on this.
Yes, so maybe to add to that, what is important is actually that refers to a study, and I think it's important to put this openly on the table, these choices, to understand the full value chain effect of these changes, and who will invest, and who will reap the benefits, and with who will stick the benefits. And if you go to the supermarket and you buy biological food, sometimes you think, this is twice as expensive. So the question is, who is now the one that grabs the value?
Yeah, maybe also the discussion we had before, who is bearing the cost, and I tried to lay out before that there is additional cost which had not been in our value chains. It's the cost of really driving recycling, it's the cost of avoiding emissions into the atmosphere. This is a cost which is completely externalized to the planet, to others. We cannot do this anymore, so there is additional cost, and there are 2 ways. One is either the consumer pays for it, or our shareholders will pay for it, because because our profitability will go down. If we cannot pass on this cost, then our profitability goes down, and then we put it onto the shareholder. But I think we have to be very clear there is additional cost going into our industrial systems, and into our cost of living will go up because we cannot externalize this cost to the planet anymore. And we have to find, and this is a socio-economic challenge. How do we do this in a fair way? Because continuing like that is also socially unfair. Because if you look into flooding, if you look into droughts, if you look at all these refugees that we have into that, that's also not sustainable. So there is additional cost, and we have to find a reasonable way to share this on this planet.
Maybe to add to that, there's also an option to reduce the amount of use of materials, right? So I think there's another discussion that nobody's having is should we grow continuously or should we arrange ourselves differently, that we use somewhat less or less growth.
Yeah. Okay, but I would like to have a quick look on the global perspective of that statement. So if you say that our basic materials essentially will become more expensive, it's steel, cement, big chemicals, whatever. This applies globally once you try to defossilize, decarbonize globally. So to what extent will that interfere with the idea of, for example, global development of the South? Because let's face it, we in Europe would be able to pay a little bit more for our stuff, but a lot of other people might not be able to pay for it. And especially with respect to fertilizers. If we talk about green ammonia, we're talking about fertilizers, which are 2 to 3 times as expensive. And therefore, the food will be much more expensive. So, how should we balance that?
I guess we just had a mini preview of this, over the last two years, with sort of the Russian invasion, prices of energy, other cascades in fertilizer prices. So I think the answer is pretty clear, right? I mean, every region is kind of going to have to figure out a contextualized solution in this framework, because it doesn't. When sort of the crisis came, it sort of went to every region for itself effectively in balancing the system. And so unless you have a global recognition of the problem and sort of a common framework under which you're operating, it becomes very hard to sort of define who takes the leadership here in being able to move this forward. Right? So I think in the European context, I would say that things like carbon border adjustments are a really compelling argument, because it sort of produces a price signal for producers outside Europe, but also producers within Europe, to sort of start acting, considering its externality, and then everybody sees the price signal. So there's no competitive disadvantage, but at the same time allows for some commonality.
Of course, love the unfair competition.
But in the market,
Shouldn't have said that. I think the issue is we have this. The planet has a surface, and all countries have to kind of find a way to live together on this surface. It's not getting any bigger unless we start settling on the moon. So we have to find a way to do this from an overall geopolitical perspective. So, and our carbon border adjustment, we can have a long debate on that, whether this is helpful or not. But I think we have to come to this global agreement that we have to do something about it, and that we cannot leverage now that one country, and this, here we go again to this basically avoiding fast mover disadvantages. So if now a certain region, a certain country, a certain company really decides, yes, I take the steps into this direction of the 1.5 degrees target, and I really do it. I don't just talk about it, just do it. We heard 10% this morning are really doing something. So then I think it's really important to ensure that we have this global agreement. And for this, from this perspective, the geopolitical situation which we are in at the moment, for me, is scary. Because if we don't come to an agreement that we are all, whether we're from India, whether we're from Germany, from Italy, from Indonesia, we are all in the same boat, then it's going to be difficult. Because then we get all this bargaining and playing around, and we lose a lot of time which we don't have to lose. So that's probably a very wise statement. So, but I think we have to really, we cannot, but this discussion that we have about decoupling and everybody going on its own, this is, for me, the biggest threat to achieving the 1.5 target. Everything else I think we can resolve. But this is really, we have to have a joint agreement among the main partners. So that's a big call for politicians. I'm only an engineer.
I think, maybe, yes, now I think we're really done somewhere discussion here. So, coming back to the original topic, we said there might be a little bit of a change necessary, there might be a change necessary, there is a change necessary, there's additional cost, this cost is bearable, there will be inflation around it. That will also lead to the fact that there's maybe a different consumption pattern needed. Is that possible? Yes, absolutely. We have learned also how to be more efficient. How it doesn't look like if you look at the waste, that's possible. So I think that's possible, and maybe important to remember that we have been here starting with the chemistry and defossilization of it. So we have that also, we said this multiple times, we have the technologies at hand, everything is at hand, it's a coordination effort, it's a cooperation effort, and nothing else. And this should be making us more optimistic, maybe. I just wanted to jump in here. Because in principle everything there, and then this adjustment is probably a natural one. And if I look at the next generation, there's of course younger people here than me, but if I look at my children's generation, I would dare to say at least, this is German bubble of course, but there's a different consumption pattern already there, and this no need to own everything is much more expensive. So probably there's also some things which are leading to that. The most important thing that I see is actually that we need to change the business model. Because our businesses are made from, we need to sell more, and this more is related to results. This is wrong. This is what leads into the catastrophe. If we can change that business model, and also that's possible, then there's a chance.
Yeah, it's a shareholder has to pay them. Okay, we reached the end of our time. Thank you very much for this lively discussion. Thank you very much to the audience for providing questions and for staying with us. And I think there will be opportunity to ask any of the panelists now during lunchtime. And I hand over to Francisco for the final remarks.
Thank you so much, first of all, the panelists and the moderator. Very good panel. I would say that from the sessions in the Innovation Week, it has been the most interactive one. Actually, the moderator could have breaks, a few minutes break where you were just checking. So it's the first time in the whole conference I see that. So this is really great, and they say time flies when you're having fun. So it really went very fast. But very good takeaways. I think the first part of the discussion was very much focused on circularity, so it shows the importance of that, and also the importance of having the right innovations to address issues such as the collection, logistical aspects, as well as the customers having a premium or the willingness to pay a premium for that, and the interaction with the waste industry. We thought about how much they like bad ideas, no? And then we need to maybe deal with that. And then on the energy part, we heard about, okay, technologies we have them available, hydrogen electrolyzers, direct electrification, but that will have an impact on the performance of the processes and the business models. So now we're going to be able to produce that much at the same price, etc. So where is the business model and who is going to pay for that? When I hear this question, I always have the same answer in my mind. I think at the end it will be me as consumer, always. So let's see, but again, I think you mentioned the point at the end is that yeah, we will pay the price, but we will have also benefit in terms of climate change, energy security, local economic sources, etc. So we need I think someone mentioned the whole global value chain picture if we really want to address. And this global, different countries have different solutions. Actually, I was expecting that some of you would talk about methanol to oil plants. No? China, we have a big delegation from China. China is producing from methanol to oil plants, but I think what Europe is producing, no, on oil plants. Just that seems to be a great solution. Why is it not happening somewhere else? Okay, let's think about it. No? But there are different solutions for different regions that we need to consider. No? So I think that's very important. I think at the end also we have these global agreements, and I think that on that I have to say I'm a little bit more positive, because as I said, the discussion 10 years ago, who would be thinking that we would have a panel today discussing about direct electrification of these processes, modularity, by the way, very interesting, the product is larger scale, we should go moderate to really be flexible. I mean, that was like science fiction 10 years ago. So just by having this discussion today, it shows that this global push and agreement is really moving forward. So I want to be positive on that. So thank you very much, all of you. Big thanks for really, really well managed the panel. And now we have the lunch break from 1 to 2 p.m. And then at 2 p.m. we will have the sessions on EV batteries materials, solution for shipping and aviation in the main auditorium. In this one we will have the future materials for EV batteries. And those interested to see our IRENA building, which is just 100 meters from here, we will have one transforming the energy landscapes in developing countries and small island development states. So thank you very much. I wish you a pleasant lunch and continue to enjoy the Innovation Week. Thank you.